Good morning, all of you. Welcome to Gender Rank Zone. Today, we are going to do that is section 5, composition of solutions. Section 4 we have completed in the previous lecture. Now we are going to do section 5. Section 5, composition of a solution. This is the last topic in this chapter. And in section 4, we discussed about laws of chemical combination as well as limiting agents. After this, immediate we'll have this topic, that is composition of a solution. So most of the chemical reactions occurs in solution. It is important to know their concentrations. Concentration here is important. Most chemical reactions occur in solution. It is important to know their concentration. Some of the terms used in this regard are as follows. So this is nothing but simple topic expressing concentration of a solution. Now first we'll have mass percentage. So mass percentage of solute, and in a solution we have solute as well as solvent. The substance which is present in lesser quantity is called solute, and the substance which is present in larger quantity are called solvents. So when you are considering mass percentage, we have to consider mass of solution as well as solute. Now solute is lesser quantity and solvent is, or solution is, larger quantity. So these are the two components of a solution, solute and solvent. Now to find mass percentage of solute is equal to mass of solute by mass of solution into 100. Mass of solution into 100. So for example, you can see here, a solution contains 15 grams of glucose in 100 grams of water. 15 grams of glucose in 100 grams of water. So here water is the solvent and sucrose, 15 grams of sucrose, 15 grams of sucrose, so is a solute. Calculate the mass percentage of sucrose. So here sucrose is solute and water is solvent. So given mass of solute M2 is equal to 15 grams. Mass of solution total mass becomes 115 grams because 100 is water and 15 is sucrose. So mass percentage of sucrose is equal to M2 by M1 plus M2 into 100. That is 15 by 115 into 100. That is simple, 13.04%. Throughout the subscripts 1 and 2 represent solvent and solute respectively. Now to calculate mole fraction. So to calculate mole fraction, this is another way of expressing solution. A solution can be best expressed in the following ways. First is mass percentage. Second is amount of mole fraction. All are similar. They are nothing but other words for concentration. The concentration of solution can be best expressed by mass percentage, mole fraction, molarity, and so on. So ppm, parts per million, and so on. So here we are discussing all these methods. Next method, second method is mole fraction, and the defining mole expressions are amount of fraction of solute, that is mole fraction of solute. Here amount fraction is nothing but mole fraction. It's better to understand like mole fraction only. So mole fraction of solute is equal to amount of solute by total amount of solution, that is amount of solvent plus solute. N2 is called amount of solute and N1 plus N2 is called total number of moles of solution. Here N2 is called number of moles of solute, and to calculate N2 we have to use the formula amount of solute. N2 is equal to given weight by molecular weight. So weight of solute by molecular weight of solute. Weight of solute, I'm writing it here again. N2 is equal to weight of solute by molecular weight of solute. Similarly, N1 is equal to weight of solvent by molecular weight of solvent. And always mole fraction of solute and solvent is equal to 1. And mole fraction is denoted by the letter chi of A. XA is equal to mole fraction of solute and XB is equal to mole fraction of solvent. XA is called mole fraction of solute, XB is called mole fraction of solvent, and always XA plus XB is equal to 1. That is sum of mole fraction of solute plus mole fraction of solvent is equal to 1. So this is called mole fraction. I hope it is clear. Next. So example, calculate the amount of mole fractions of solute and solvent containing 18 grams of glucose and 90 grams of water. So they have given solute is glucose, 18 grams of glucose and 90 grams of water, that is solvent. Now to find amount of solute, that is mole fraction of solute, N2 is equal to given weight by molecular weight. Given weight of glucose is 18 grams. Molecular weight is 180 because glucose formula is C6H12O6. C6H12O6. So glucose formula is C6H12O6. So 18 grams to 180, that is 0.1 mole. The amount of solvent is equal to molecular weight by molar mass of solvent. That is 90 grams by given weight is 90 grams and water weight is given already. It is 18. Molecular weight of water is already 18. So it is 5 moles. Now amount of fraction of glucose is equal to N2 by N1 plus N2. That is 0.1 by 5.00 plus 0.10, which is coming around 0.020. Similarly, amount fraction of water X1 is equal to 1 minus X2, that is 1 minus 0.020, which is equal to 0.980. In this way, you will find mole fraction of solute. Mole fraction of solute. Next, and mole fraction of solvent. Next question. Next, we have molarity. This is another third way of expressing concentration of solution. It is called molarity. So molarity is nothing but amount of solute by volume of solution in liters. Volume of solution decimeter cube means liters. So how to find amount of solute? Given weight by molecular weight. Given weight by molecular weight. So molarity is equal to N2 by V, where N2 is called N2 is called amount of solute and V is called volume. So amount of solute, how will you find? Number of moles of solute. You can use by formula molecular weight, given weight by molecular weight. Number of moles of solute is equal to given weight by molecular weight. So we can write the same molarity formula. M is equal to weight of solute by molecular weight of solute into 1000 by V if volume is given in milliliters. Weight of solute by molecular weight of solute. I'm writing it here again. Capital M is equal to weight of solute, small w, by molecular weight of solute into 1000 divided by V. If the volume is given in milliliters. If the volume is given in liters, just by V. So in this way you can find out. So for weight of solute, we'll write this letter W. Small w is called weight of solute. Capital M is equal to small w by molecular weight of solute into 1000 by V. So this is the actual formula for finding molarity, and molarity is moles per liter because amount of substance is mole and volume is liter, so moles per liter. This unit is commonly abbreviated for the symbol capital M, Roman style, and is spelled as molar. Molarity is temperature dependent as the volume of solution varies with temperature. So molarity is temperature dependent as the volume of solution varies with temperature. So now we'll see question related to molarity. Calculate the molarity of glucose containing 18 grams of glucose in 90 ml of an aqueous solution. So here the volume is given 90 ml and amount of glucose first we need to find, that is molecular weight by molecular weight, that is 0.1 mole. Here 18 grams by 180. 18 grams 180, it is equal to 0.1 mole. So that is amount of substance, that is number of moles, and volume is given 90 ml. So it can be written as 0.090 liters. And straight away by applying the formula, M is equal to N2 by V, 0.1 by 0.0090 liters. We got the answer 1.1 moles per liter. So this is called molarity. Now next, expressing the concentration of solution, molality. So molality is equal to amount of solute by mass of solvent in kg, which we can write it as N2 by, that is equal to small m. Molality is always represented by the letter small m. Small m is molal, 1 molal. So m, small m is equal to N2 by mass of solvent in kg, that is capital W. Capital W is called mass of solvent in kg. So mass of solvent in kg, N2 by W. So simply you can say moles per kg. This unit is also called as molal. This unit is also spelled as molal. So the molality is temperature independent quantity. Molality is temperature independent quantity, and molarity is temperature dependent quantity because it is depending on volume. Since volume is directly proportional to temperature, so molarity capital M is temperature dependent quantity, whereas molality is temperature independent quantity. So let us see one example, solid example. 10.6 grams of sodium carbonate, molar mass 106 grams per mole, is present in 100 ml of aqueous solution. 100 ml of aqueous solution. Here they have given volume and they have given molar mass, and 10.6 grams is sodium carbonate. Calculate the density. If the density of the solution is 1.018 grams per meter, calculate molality of the solution. So the relation between molality and density now we have to acquire. Now amount of solute is equal to N2 is equal to given weight by molecular weight, that is 10.6 by 106, it is equal to 0.10. Mass of solution is equal to density into volume. Since mass is equal to density into volume, so we can say density is given 1.018 into volume is given 100 ml. So 101.8 grams. So mass of solvent is equal to M1 is equal to mass of solution minus solute. So 101.8 minus 10.6, that is equal to 91.2 grams. So 101.8 minus 10.6. So 91.2 grams can be taken as 91.2 10 to the power minus 3 kg. So molality of sodium carbonate is equal to N2 by M1. So 0.1 by 91.2 in 10 to the power minus 3 kg, it is equal to 1.096. It is not direct question, it is indirect question. In this question, they are given, instead of giving mass of solvent, they are given volume of the solvent as well as density of the solution. So from density and volume, we can find mass of solvent. By using that, we can find molality of sodium carbonate solution. So in this way, we'll find molality. Molality is always represented by small m. Molarity is represented by capital M. Capital M and small m, that is the difference. And small m is also spelled as molal, molal solution, molal solution. Next. Now, these are the four ways. Apart from this, we have one more important way of expressing concentration of solution. Here I am writing it, parts per million, ppm. Parts per million, parts per million, ppm. This is very small amount. If the solute is of very small amount, we'll use this concentration, that is called ppm, parts per million, ppm. Number of parts of solute in 1 million parts of solution by weight. Number of parts of solute in 1 million parts of solution by weight. In 1 million parts of solution by weight. By weight is called by weight. Number of parts of solute in 1 million parts of solution by weight is called parts per million, ppm. So generally hardness of water is expressed in parts per million. Example, hardness of water, because it is very less amount, so that's why hardness of water is expressed in parts per million. Also concentration of pollutants expressed in ppm. This is the best example, hardness of water. So it is 1 ppm, 2 ppm, like that say. So it is nothing but in 1 million parts of solution, one part, it is called as parts per million. That is 10 to the power of 6, 1 by 10 to the power of 6. You can write 1 by 10 to the power of 6. It means it is equal to 1 ppm, because 10 to the power of 6 is 1 million. So 1 by 10 to the power of 6 is 1 ppm. So in this way, we can express concentration of solution. So totally we have total expressing concentration of solutions is first one we have mass percentage, second one we have molarity, third one we have mole fraction, fourth one we have molality, and fifth one we have parts per million. So these are the 5 methods of expressing concentration of solution. Still we can have mass percentage and mass by volume percentage also, but that you will be learning in the class 12 or even class 11 also. But these are very most important, so that's why all these are very very important. So molarity and even normality is also a special case of molarity. In normality we will consider equivalent weight, and molarity will consider molecular weight. So coming to, based on this concept, we have questions right now. We'll discuss all those questions. Yes, multiple choice questions on this concept, that is expressing concentration of solution. First one, the mass of sodium carbonate to prepare 400 ml of 0.275 molar aqueous solution. Molar aqueous solution, they are asking us to find mass of sodium carbonate, and they are given volume is given. So molar aqueous solution, and here they are given volume. Since molarity is equal to N2 by V, we have amount of sodium carbonate required is equal to M into V, that is 0.275 into 0.40 liters, which is equal to 0.11 moles, because amount of sodium carbonate is equal to N2 is equal to MV, and they are given molar aqueous solution. So mass of sodium carbonate required is equal to M is equal to N2, M2 is equal to 11.66 grams. A simple way we can write like this. I'm explaining in simple way. Just one moment. I'm taking new slide. Yes. In simple ways, in this question, what they have asked, they have given molarity and they're asking amount of solute. So we know the formula, molarity is equal to capital M is equal to weight of solute by molecular weight of solute into 1000 by V. Molecular weight of solute into 1000 by V. And they are given in this case, molarity capital M is given, and weight of solute is we have to find. Molecular weight of solute we know, and volume is also given. So by substituting weight of solute is equal to, we can say weight of solute is equal to molarity into molecular weight of solute into volume. Molarity into molecular weight of solute into volume by 1000. So if you substitute this, you'll get the answer clearly. So opening to the previous slide. So molarity is given 0.275, volume is given 400, and molecular weight of sodium carbonate is 106. By substituting that values and which are given the formula, that formula if you apply, you'll get the answer 11.66 grams. So answer is B option. Next question. The density of CaCOH is 0.80 kg per liter. Here they are given density. Density is equal to 0.080 kg per liter. And the volume of methanol to be prepared 2.5 liters of 2.5 liters volume should be prepared 2.5 liters of 0.25 molarity solution, 0.25 molarity solution. So aqueous solution. So they are asking volume of methanol. Methanol formula is CaCOH. Density is given, molarity is given, volume is given. And you know, from molarity, M is equal to weight of solute. Writing it here, molarity M is equal to weight of solute by molecular weight of solute into 1000 by V. And in this case, we have to find this V only. V is equal to how much? And weight of solute is not given directly. So from density and volume of methanol solution, we can find weight of solute. So density of methanol is given 0.880 kg per liter, and volume is given 2.5 liters. This volume is for only methanol, not for the molarity volume. And straight away we can write mass is equal to weight of solute, that is equal to weight of solute is equal to weight of solute is equal to, that is methanol, is equal to density, that is 0.80 into 2.5, 0.80 into 2.5, which is coming around calculation part. So 0.80 into 2.5, the 2.5 is equal to 2. Weight of solute is equal to 2 grams. And now you know the weight of solute, molecular weight of solute. Just substituting this, and molecular weight of methanol, CH3OH, that is 0.25 is equal to weight of solute, that is 2 grams by CH3OH. Carbon is 12, hydrogen is 3, and oxygen is 16, and again hydrogen is 1. So 12 plus 3, 15 plus 16, 31, 31 plus 1, 32. So 2 by 32 into 1 by V. 1000 V is not required here because already volume is given liters. So even if you take 1000 also, you'll get in ml. So 1 by V. So from this you can find V is equal to 0.25 into 32 divided by 32. 0.25 into 32 by 2 and 2 16 times. So 0.25 into 16 is equal to 4. So answer is 4 liters. Answer is equal to 4. So we can check the option. So in this way you have to do the answer. Question slide. I am moving to question slide. Yes. The question said we have 45 ml, we will get the answer. So 32 ml. I'm saying here the answers also, options. You can just check. Question number 3. Option is, no, question number 4 we are doing. So mass of ethanol, no. Question number 2, actually, sorry. Question number 2, it is A option. That is 25 ml. Because from 2.25 liters, we have to take that also. So next question. The mass of calcium carbonate that reacts completely with 50 ml of 0.75 molarity HCl is. Calcium carbonate, they have given 50 ml, they have given volume, and molarity is also given 0.75. So applying the same formula. Next, I'm solving this problem. Question number 3. Question number 3, we are solving it. So just see the next slide. 1 minute. Just note down the values. We have to find weight of solute, which is to be find, and volume is given 50 ml. So we have to convert it into, no need to convert liters also, directly you can take, and 0.75 is the molarity of HCl. Now molarity is equal to weight of solute by molecular weight of solute into 1000 by V. In this question, they have given molarity capital M is equal to 0.75 and weight of solute is X. We have to find that only amount of calcium carbonate, and molecular weight of solute calcium carbonate is 100 CaCO3. So CaCO3, calcium 40, carbon 12, oxygen 16, 16 is 48. We'll get it as 100 into 1000 by volume is given in ml. So that's why we are taking 1000 and volume is given 50. So by this we can write X is equal to 0.75, 50 by 200. So here 50, how many times it will go? 20 times. So X is equal to 0.75 into 2 into 100. That is, no, 0.75 into 100 by 20. from which you will get 0.75 into 10, 0.75 into 5 finally. So 0.75 into 5 comes around 3.75 grams. So answer is 3.75 grams. That is the weight of solute to be dissolved. So moving back to question. Yeah, first option, that is 3.75 grams we have got. So answer is A. Next, the mass of methanol to be added to 1 kg of water so as to have its amount fraction. So I have to have its amount fraction means mole fraction equal to 0.2. So they are asking, they have given mass of ethanol to be added to 1 kg of water. So they have given molality we have to find, because 1 kg of water is given, mass of solvent is given. So that amount of fraction, that is mole fraction, equal to 0.2. So mole fraction of solute is equal to total mass of solution and this. So by this you can see here, if you see the hint, directly I'll show you the hint. By definition, X2 is equal to N2 by N1 plus N2, where X2 is called mole fraction of solute. So N2 is called amount of solute by total number of solution, that is N1 plus N2. So hence X2 into N1 plus N2 is equal to N2 we can write, because by taking cross multiplication. X2 into N1 is equal to 1 minus X2 into N2, because X1 plus X2 is equal to 1. So since X1 plus X2 is equal to 1, so instead of writing X1, we can write 1 minus X2. So X2 into N1. Perfect. Two. Otherwise, leave it defined. So x2 into n1 plus x2 n2 is equal to n2. Our x2 n1 is equal to 1 minus x2 n2. This is how we got, since x1 plus x1 plus x2, that is mole fraction of solute, and mole fraction of solvent is equal to 1. By substituting this, x2 n1 is equal to x1 n2, or n2 is equal to x2 n1 by x1. Here n1 is equal to given weight by molecular weight, that is 1000 grams, because 1 kg by molecular weight of water is 118 grams, that is 55.56 moles, and n2 is equal to 0.2 into 55.5 divided by 0.8, that is 13.89 moles. So mass of methanol required is N2 into M2, which is equal to 13.89 into 46 grams. So it is equal to 638.9 grams. 638.9 grams. In this way, you have to find mole fraction of solute and the amount of substance. Next, question number 5. It is 638.9. Why it is scratching? Question number 5. The density of 2 molarity solution of acetic acid in water is 1.01 grams per centimeter cube. The molarity of acetic acid in solution is, they're asking molarity of solution. Molarity of the solution here. So here the density is given, density of 2 molarity solution of acetic acid in water is 1.01 grams per centimeter cube. And they're asking us to find molarity of acetic acid in solution. Molarity of acetic acid in solution. So here, open the slide, hint. You can see here directly hint also given. For 2 molarity solution, we'll have amount of acetic acid. N2 is equal to 2 moles. Volume of solution V is equal to 1000 centimeter cube. And mass of solution is equal to density into volume. Up. Stop. Now here we see 2 molarity solution. We have amount of acetic acid is equal to 2 moles, and volume of solution is 1000 centimeter cube. And mass of solution you can find, and you'll get it as 1010 grams. Underneath. So volume is given, and 1010 grams. Mass of acetic acid is equal to number of moles into molarity of the solution, that is 60 grams per mole, that is 120 grams. Mass of water in 1010 grams of solution, M1 is equal to 1010 minus 120 grams, that is 880, which is equal to 0.890 kgs. And molarity of acetic acid is equal to M2 by M1, where M2 is called weight of solute. So finally, you'll get 2.25 moles per kg. Next question. Question number 6. Question number 6. A solution of acetic acid has molarity equal to 1.35 molarity and molality equal to 1.45 moles per kg, the density of solution. Since they are given molarity as well as molality and they are asking us to find density of solution. From molarity we can find weight of solute, and from molality we can find weight of solvent, and by using this we can find density of solution. And you can see the options here. So for 1.35 molarity solution, we'll have N2 is equal to 1.35 moles, because N2 is called weight of solute by molecular weight of solvent, solute. Weight of solute by molecular weight of solute is given 1.35 moles and volume is given 1000 ml. The solution is also 1.45 moles per kg. So the mass of solvent to have 1.35 moles of solute will be M1 is equal to 1.35 by 1.45 moles per kg, which is coming around 931.03 grams. Since we have got the mass of solute, we can find volume of solution also. And after finding volume of solution, we can find density of solution, that is mass by volume. So the mass of solution will become M1 plus N2 M2, where M1 is, we have solved it, that is 931.03 milligrams plus 135 moles into 60 grams per mole, that comes around 1012.03 grams. So then density becomes 1012 by 1000, which is equal to 1.012 grams per milliliters. So in this way, these are all difficult problems, but still you can understand by using 2 or 3 times, 100% you'll understand just by applying the formulas. Now question number 7. The density of 3 molar solution of sodium thiosulfate, formula is given Na2S2O3.5H2O, solution is 1.25 grams per centimeter cube. The percentage by mass of sodium thiosulfate is. So first, from density we can find molar solution, we can find mass of solvent, and after that you can find by using 1 point density also they are given. So finally you can find mass of sodium thiosulfate, and in that total mass of mass percentage of sodium thiosulfate also you can find. So what is given here? Only density is given, that is 1.25 grams per centimeter cube, and molar solution of sodium thiosulfate is given. 3 molar solution of sodium thiosulfate. Now see how we'll work out for this problem. So question number 7. So molar mass of sodium thiosulfate is given based on the formula. We got it as 248 grams per mole. 248 grams per mole, that is molar mass of sodium thiosulfate, because sodium is 23 and sulfur is 32 and hydrogen is 1 and oxygen is 16. So by substituting this, our directly 5 water molecules if we take, we'll get 248 grams per mole. Now the mass of 3 moles of sodium thiosulfate is 3 moles into 248 grams per mole, because mass is equal to, so molarity into this thing volume. So 3 moles into number of moles, 3 into 240, that is 744 grams. Now the mass of solution will become M1 plus M2, that is 1000 plus 744, that is 1744. Now mass percentage of sodium thiosulfate is M2 by M into 100, that is 744 by 1744 into 100, which is coming around 42.67%. 42.67%. In this way you can find mass percentage of sodium thiosulfate. Now question number 8. Question number 8. The molarity of sulfuric acid is given directly. Here the molarity of sulfuric acid is 2.32 moles per decimeter cube. That is moles per liter. And if the density of solution is 1.14 grams per centimeter cube, then the molarity of the solution is, they're asking us to find molarity of the solution. And in this case, we can find in a different manner by using molarity and mole fraction. The relation between molarity, mole fraction, density, we can obtain by using the following exception. Molarity is equal to, writing new formula, please note down this formula. For all the above problems also, we can do this shortcut formula. Small m is equal to, that is molarity is equal to capital M, that is molarity, into 1000 by 1000 into D by capital M, that is into gram molecular weight, into gram molecular weight. This is a direct formula. By using this, we can find molarity, mole fraction, everything. So by using this formula, this is molarity and this is density. And we can find this is not molar, yes, molarity into gram molecular weight. Now by using this formula, you can apply. So if you see the previous question, we can do like this. So once again, I'm going back to previous question. Previous question. Yes, here they are given molarity of sulfuric acid is 2.32 moles per liter. Density is given, molarity of the solution. So straight away we can find out using the formula. Now I'm applying this formula. So molarity is given, capital M is given 2.32. This capital M is given 2.32. Density is given 1.14. And now they're asking molarity of the solution. So there is a direct link for this. So what is the link? Again, I'm writing the formula. Please note down. M is equal to small m, that is molarity of the solution, is equal to molarity of the solution, small m, is equal to capital M into 1000. This is a short formula. For the previous problems also, you can use this formula, by 1000 D minus molarity into gram molecular weight. So by substituting this formula, molarity is given as 2.32. 2.32 moles per liter is given into 1000 by 1000 into D, that is density is given 1.14 minus molarity, that is 2.32 into molecular weight, gram molecular weight of sulfuric acid is 98. Now solving for denominator, 1000 into 1.14, numerator I'll keep like this, and denominator we are solving now. 1000 into 1.14 is equal to 1140. So numerator I'm writing as it is 2.32 into 1000 divided by 1000 into 1.14, that is 1140, minus 2.32 into 98 into 98, which is equal to 227.36. 227.36. So now again 2.32 into 1000 and denominator 1140 minus 227.36. 227.36 is equal to 912.64. 912.64. Now finally we'll get 2320 divided by 912.64, which is coming around 2.54 approximately. So answer is 2.54. Molarity of the solution is 2.54. Now let us see the options. Yes, first option, eighth question, 2.54 moles per kg. So for the previous questions also directly you can do the question like this. After finding density also you can find volume. So next question number 9. Here question number 9, they have given volume, 2 molarities. So when 2 different molarities are given, we have to find the resultant molarity of solution. Now here you just see, if 20 centimeter cube of 1 molarity calcium chloride and 60 centimeter cube of 0.2 molarity calcium chloride are mixed. So 1 molarity calcium chloride and 2 molarity calcium chloride. But here they have different concentrations. They are having different concentrations. So I'll mix it. The molarity of the resultant solution is, we have to find the molarity of the resultant solution is, so in this case, we have to find molarity of the resultant solution. So when two solutions are given, to find the resultant molarity, we have the formula M1V1 is equal to M1V1 is equal to M2 plus V2. M1V1 is equal to M2V2, sorry. M1V1 is equal to M2V2. By using this formula, we can write here, ninth question formula is M1V1 is equal to, for ninth I'm writing here, M1V1 is equal to M2V2, capital M and capital M2. So this is a formula for finding resultant molarity of the solution. And they are given, or you can write M1V1 plus M2V2 M1V1 plus M2V2 by V1 plus V2 is equal to M3. We have to find in this question M3. So M1 is given 1 molarity and V1 is given 20 centimeter cube. M2 is given 0.20 molarity and V2 is given 60. So by substituting this, and V1 plus V2 is equal to 60 plus 20, that is volume centimeter cube is nothing but mLs. So 20 plus 60, 80. So by substituting this formula straight away, you'll get molarity of the resultant solution, and the answer is C, 0.40 molarity. Next, question number 10. The concentration of ethanol in the solution is called 86%, vodka is 6.86, proof vodka is 6.5 molarity. So if the density of the solution is 0.95 grams per centimeter cube, the amount of fraction of ethanol in vodka is. So they are asking amount fraction of, that is mole fraction of ethanol in vodka, and they have given 86%, vodka is 6.5 molarity. Now here you can see the hint, already it is given. So for 1 liter of vodka, we have N2 is equal to 6.5 moles and V is equal to 1000 centimeter cube, because N2 is called what? Number of moles of solute, and it is given 6.5 moles. And mass of solution is called density into volume. So 1000 into 0.95, which is coming around 950 grams. And mass of ethanol in this is 6.5 into 46 grams, because the molecular weight of ethanol is 46. So 299 grams. So mass of water becomes 950 minus 299, which is coming around 651 grams. So amount of water is equal to, that is N1 is equal to M1 by M1, that is 651 by 18, which is coming around 36.167 moles. And the amount of fraction of ethanol, that is mole fraction of ethanol, X2 is equal to N2 by N2 plus N1, N2 by N1 plus N2, which is equal to 6.5 by 36.167 plus 6.5, which is coming around 0.152. I hope this is clear. And more questions based on concentration of solutions, you can do it in exercise, which I'm going to give you the last of this chapter. So I hope this is useful for you. Thank you.